Today we will be looking at more geometric series and infinite series. So remember, we're just going to replace the ends with a whatever term number we're looking at. So A1 would represent the first term. And we can type this into a calculator exactly like we see. This does end up giving us -2. Now we'll do the same thing for the second term. This time we'll replace the n with a 2. Let's see, 3 times 2 is 6. 6 minus 2 is 4 squared, 16, times -2 is -32. And we will continue this process until we have all 5 terms. The third term does end up giving us -686. The fourth term, -20,000. And the fifth term, 742,000, -586. That's it. Take a minute or two and try this example you try. So hopefully for this one, you found the first term to be 4, the second term 36, the third term 500, the fourth term 9,604, and the fifth term 236,196. Okay. If we look at our next example, we're just going to be doing the same thing. We're going to find the first 4 terms this time with a more complex sequence. Just like we did before, we'll replace the ends with the term number we're referring to. We know -1 to the first power is a -1, and our fraction is 3 over 2. So this gives us -3/2. Now let's find the second term. So remember, we'll replace the ends with a 2. And simplify. -1 squared is +1. We'll have 4 over 5, so this is 4/5. We'll find the third term next. -1 to the third power is a -1 times 5 over 8, or -5/8. And the fourth term will replace all the ends with a 4. -1 to the fourth power is 1, and that would be times 6 over 11, which gives us 6/11. And that's it. Take a minute or two and try this example you try. So when we talk about the sum of a finite series, or infinite series, excuse me, that means a sequence that does not terminate. It goes forever. So if I know my ratio is less than 1, the infinite geometric series has the following sum. So notice we have an infinite sum up at the top. It's an infinity sign instead of a stopping number. And our sequence is a1 r to the I power. Then we can say a1 e over 1 minus r is what the sum approaches or is. Okay, so if we look at our next example, notice that we have an infinity sign at the top. And that tells us that our sequence is infinite for our sum. So we know our sum formula is a1 over 1 minus r. Well, we need to figure out what a1 is. a1 is 3/8 times -1 over 2 to the 1 minus 1 power, or just 3/8. So we're going to start off with 3/8. We know our common ratio is whatever is raised to the power, so the r is negative 1/2. So we'll do 3/8 divided by 1 minus our common ratio, negative 1/2. Or 3/8 divided by 1 plus 1/2 is 3/2. And remember, when we divide fractions, we multiply by the reciprocal of the divisor. And we do get 1/4. Let's look at another one. So we know in letter B it is infinite because of these dot dot dots. We know the first term is 1, and to get the common ratio, if we take the previous two terms and divide, so negative 1/4 divided by 1 is negative 1/4. So we can use our formula S equals A1 divided by 1 minus the common ratio. Okay, 1 divided by 1 minus the negative 1/4 ends up being 1 1/4 or 5/4. And then when we divide fractions, we multiply by the reciprocal of the divisor. In this case, our sum is 4/5. I want you to take a couple minutes and try these two last example U-tries. So hopefully for letter A, you did find a sum as 9, and for letter B, the sum is negative 20. It's time to try some practice. The end.